happy being here with you. My name is Sotiris Xydis. I'm an assistant professor in National Technical University of Athens, and I'm representing the computing guys, right, from Mafusa and the RefMap project. Today we will focus on the RefMap platform, the RefMap Analytics platform, because there are actually two branches in the RefMap project. One regarding the analytic platform, and another one regarding the workflows that will drive the simulation, which is driven by AFT, by Milan. So you have already hear about what RefMap is about. Is about creating a digital service that will optimize aviation both at the macro, so ATM, and micro levels, UTM, but with more than one objectives with respect to cost. So we are also taking into consideration environmental impact like noise, wind, emissions, as well as building an ecosystem for, let's say, eco-friendly aviation. There is a lot of great partners working in Mafusa. We are now towards the, let's say, the last semester, let's say, of the project. So the platform is getting ready. It's not everything there, and the final, let's say, view of the platform will be something like this. It is the analytic platform. It will have several tools. The user could select either large-scale analytics tools for aviation or small-scale analysis for UTM. There will be a demo also afterwards. So we have 6 big categories of tools. The first one is on the climate impact, is how routes could be optimized for aviation, taking into consideration emissions that affect the climate. The second tool is analysis of emissions. The third one is atmospheric pollution analytics, mostly concentrated near the airport. So, let's say, analyzing the interaction also between UTM and ATM. The fourth, fifth, and sixth tool are mostly related to UTM. So it is path optimization based on very high fidelity CFD analysis for within the cities. Gerardo will also talk later on that. There is noise assessment tool on scoring or validating different routes within the cities with respect to noise, and in future developments also with the collaboration with other emissions. And the wind assessment tool, which tries to, let's say, to formulate a map of the city regarding to nonlinear airflow features like turbulence, like airspeed, in order to recognize, to identify good areas for path planning. More details later in the demo. Now I will just spend some slides on, let's say, the main challenges that this platform at least bring in front of us. We start approaching this project basically considering this one, that okay, there will be a platform, there will be some visualization, great. To be honest, our main research work in the project was mostly focused on high-performance computing for CFDs, right? But this here was a real monster, to be honest, and we are still trying to address it, right? Because it is like this tip of the iceberg. You see this and you say, okay, there will be an analytic platform, analysis will be provided by the partners, But then there are other objectives that start popping up during the development. So the platform should be designed in a user-friendly manner. So there are issues about user interface design. The platform is collecting analysis, data, tools from different partners. So there is a lot of workload diversity, which is very hard to be managed in let's say, real ICT solutions. And this difficulty is squared in this project because there are also different runtimes. So there's no everything on Python, right? Not everything on MATLAB. There is Python, MATLAB, C++, Fortran, a lot of different technologies to be integrated. And there are also another two challenges. Ignacio more or less, let's say, discussed about these challenges. We have also started addressing these in this preliminary version. The first one, and the most important for us here, was the need for high performance computing. So analysis was not something easy to be run on a big server, right? I'll show you also later. We needed access to big infrastructures, and there is also the need for, let's say, big data manipulation, both from the analytics point of view, also from the storage point of view. Here, in this state of the platform, this one is mostly popped up due to the machine learning, the artificial intelligence capability that we want to employ to help this one. But it is already, let's say, foreseen that if this platform, this type of platform, would like to be scaled up, right? This one is a real monster. I mean, it is very difficult. There are already per analysis close to 1.5 terabyte of data needed for just one case, right? One case means one spot in the city. So what have we done up to now for tackling this type of challenges? For the high performance computing, we had to access very big infrastructures, hopefully with the collaboration of KTH, Gerardo. We had access to two big infrastructures in Sweden, Berzelius and Lumi. There are issues on cross-vendor, right, mapping. There is not always the same infrastructure available. There was an issue on the actual performance. We decided to tackle this problem, extending the current state of the art of the CFDs with multi-GPU simulation. This was not enough. We had to optimize further, so to go towards auto-tuning techniques. By the very end, the first, let's say, path, which was on the high-fidelity simulations for path planning, UTM path planning, we managed to have an acceleration of between times 10 to times 15, only from mapping to multi-GPU infrastructure. And on top of that, we managed to have up to a 4 times acceleration based on our, let's say, scenario-specific optimizations that we have in our code. There is also another path, the so-called low-fidelity simulation, because RefMap it is based on this multi-fidelity framework, especially for airflow, for wind assessment. Here is another data example of this workload diversity. While in the first part, everything was deployed in a large infrastructure, in the lower part, we had to address several deployments, but a really massive set of deployments. Again, needed acceleration, again with GPUs. Over here, we managed to have, by integrating sparsity optimizations, around to 7 times optimizations. And all these are propagated data to our platform. Now, what about the workload diversity? Here, the strategy that we followed was separation of concepts. So we separate front-end analytics, front-end services with respect to back-end services. Front-end is user interfacing plus visualizations. Here is not so easy, as we said, visualization, yes, but visualization consumes a lot of data, so there was also caching mechanism needed. Versus backend analytics. Backend analytics is the heart of this platform. The real type of analysis, the real simulations, the real filtering of the data is here. And here is also this workload diversity. You can see that a lot of different technologies are used either for analyzing or for storing the data. So what we decided to do about this diversity in order to be manageable and be ready for a larger scale infrastructure, we used nowadays, at least nowadays today, a mature technology called containers. You can consider this as packaging different type of software of runtimes. Here with Docker is the technology of use. And this one allows at first to deploy in the same infrastructure different runtimes, different tools, and being able to scale, right? If for some reason I need 20 analyses together, it's okay, I can deploy on demand 20 different MATLAB analytics or analytic executables or 20 different Python containers with Python. So this one over here, this containerization makes our platform, we call it cloud ready, right? We develop once in our laboratory, on our infrastructure. We have the opportunity to have real good infrastructure, state-of-the-art infrastructure in our laboratory, but it is, let's say, zero effort deployable in a cloud platform, zero effort in quotas. It needs some, let's say, development for mapping, but nothing too has to be rewritten. And the third, let's say, strategy that we followed to enable this cloud readiness is this block over here. So we separate concepts, front-end versus back-end, but when we need to scale on demand, we need somehow to orchestrate our resources, right? We cannot consume one cluster, one supercomputing cluster every time that someone accesses the front-end platform. So here we also linked these containerized, these packaged tools with so-called Kubernetes infrastructure, Kubernetes orchestrator. This is also today available in most cloud providers in order to enable this on-demand scaling of our infrastructure. The fourth challenge, right? Effective user interfacing. So the strategy that we followed here is completely sweeping complexity, let's say, under the carpet, under the rug. And how we did that? We tried, Yorgos here is the main intelligence behind all this, to minimize all the user interaction. Why? Because there are a lot of analytics, a lot of details. We are, as engineers, we were not able to follow, right? What Milan was providing, what Gerardo was providing, what Fateme was providing. So we tried to design by, let's say, hiding all this complexity, providing very specific tool documentation in order for the user on the platform, in order for the user to be able to follow the parameters, and the main interaction of the user to be only on informative visualizations plus expressive filters, right? And what I'm meaning about filters and visualizations, we will show it also later. For example, here there are tons of analytics and optimizations run in the background, but at the end, the user interacts only with map-based visualizations easy to perceive metrics. Here is the climate impact tool, right? So it is the, let's say, the comparison with business as usual change of routes according to climate impacts, and filters, where here you can just select parameters, high-level parameters, cost-level parameters of to define the desired analysis. The same also here. Again, this is the wind assessment tool. Again, here it is a filtering. Let's say you can see, right? Minimal interaction, filtering on the basic parameters, plus let's say easy to use control of. This is to control the, let's say, the direction of the wind, and one simple visualization. So all the tool is built on this. The RefMap platform is built on this concept. But to be honest, the main and above all asset, right, of being able to build this platform, except from the technologies, the digital solutions, the high performance computing, are the people, right? I can guarantee you that there is a massive communication, and thank all partners for that, and especially Yorgos, because he is driving this. Every week, mail after email, documentation after documentation. And if there is no effective partnership, so providing inputs, all having the same goal, then this type of platform is not possible to be delivered. So from my point of view, this was a very brief description of the challenges of the platform. I would like again to thank my team in National Technical University of Athens. We are in the microprocessors and digital systems laboratory, and except from Yorgos, I have the pleasure to work together with Konstantinos Iliakis, our postdoctoral researcher, Panagiotis Eleftherakis, who is here, and our newer member of our team, Anastasis. These guys here are providing all the magic for HPC, artificial intelligence, and the platform. And I would like to thank you in public. So, from my point of view, this is the, let's say, the presentation of the overall platform. I think that now we can proceed to the actual demo, right? With Yorgos, and please, let's say, be aware, because it will also help to answer this survey that the
Iliakis just... We will follow the order of the questionnaire so that you can map. So they were showing you a preview, and this is still in development, so not everything is perfect. But since the project is finishing in January 26, but we have already like the main stack, like the beta version is there. And what we're asking you is to evaluate the features, like which feature do you find more useful than another feature. So you just order in from 1 to 10 the features that you find most useful. So that is the exercise.
We'll try to follow the survey in the demonstration. We should start with the set of wind assessment tools. There are two different types of tools. One on path optimization. This is not yet ready, right? But the wind risk assessment tool, it is ready, and we can start from this one. Please show the platform, show the capabilities.
Hello everyone, from me, I'm George Anagostopoulos, a PhD student at NTUA and part of the ICCS team. And we are going to do a quick overview of the platform, right? So, starting with the risk assessment tool, we can see that we have above the different type of filters. Every tool follows the same layout, so the user won't be disoriented when moving from tool to tool, right? And here we have four main ones. The level of detail, which basically is in how fine-grained was the simulation and how well was the structures in the simulation that have been executed. The city, that that the simulation has happened, right? And then we have two parameters, the turbulence level and the wind speed. We are going to go with the wind speed. It's more visually understood at the moment, right? And here we can select the different altitudes. So here it appears a color bar, right, depicting the wind speed, and on the side we have the direction of the wind. If we zoom in on the map and go to the appropriate city, we can see that here we have the wind direction, where red means that we do not have any wind speed, and blue that wind is affecting the airspace, right? And we can change by clicking on the compass the wind speed, and we can see the direction that it goes and how it affects the wind speed in the city. This is important because this can help people understand what routes to take in order to minimize the risk of the flight path, right? And also, this could also help see where would the best spots for takeoff and landing would be. Because if we have no wind in some spots, it would be better in order to land and take off from there, right? Also, regarding the altitude, we can, if we go to 10 meters, let's say, we can see that here we have a lot more wind speed because we are above many of the buildings. And this can also help see in different altitudes how wind might affect the path trajectory. The next tool.
So in this one, you can imagine that according to different weather conditions, right? For example, it is Tuesday morning and the wind speed is from north to south, or this specific, let's say, speed. Then, according to this map, you can reroute your flight paths, right? This tool is developed from our partner TU Delft mostly. And there are, let's say, in the survey, a different set of tools. Don't worry about the names, are mostly specific technologies that support this type of analysis. If you have any questions, and we can answer it, because we are not the yes?
Just a quick one. So the data that are created in order to see the result of the input that you have put, is it downloadable?
Downloadable. If it is free, if they are free, you mean, right?
Both. Is it downloadable, either free or is
downloadable? No, because there are several gigabytes, right? Something like 300 gigabytes, something like between 300 to 400. Because this one, actually, it is per how we call it, mira?
Per degree.
Per degree. One different CFD simulation on the center of the Han city. So there are a lot of data. So downloadable. Yes or no? Free. I'm not the owner of the data, to be honest, but as Anna said in the beginning, since these data are generated within a European funded program, somehow it would be.
But my idea also, it was not to download everything, right? However, I run a simulation that fits me now or fits a scenario that I want, and I want only this part that is shown there now. So I don't have to download all 300.
Yes, more or less now it is something like that, because we have pre-run. There is not only these two cities that we are providing, but we have filtered out data according to these parameters and the cities and collected. But even for one city, I mean, the data are massive.
But from what I know, the software is open. The TU Delft is particularly this partner. All of their software is open. The data, I mean, you can contact them and, collaborate. Like, it's not like behind bars because it's from a university. So that I know because we're also doing the exploitation plan, and that is part of what they told us. Yeah. We unfortunately don't have anyone from TU Delft with us today, but we can connect.
Other questions? Yes.
I have two questions. So the first one is, I wonder where do you get the data from in order to work on this project? And the second one, what is the purpose of this project? So do you have a specific target audience or organizations perhaps?
Let me answer first on the data, which is easier for me. The data, most of the data, are being generated within the project. So this one over here are simulations that have been run during the project, and we collect the data. Probably, I don't know all the data. Probably there are, not for this case, but for the other cases, probably there are some data used from other sources, right, in other type of analysis. But for this one, all data have been generated during RefMap project. And the same also for the other wind, the path optimization tool, which again wind related. Now,
When you mean you generate the data, do you mean that you derive it from other data sources?
no, we run the simulations. The CFD simulations. This is the low fidelity ones. This have been
For the path optimization as well?
for the
Path optimization?
for the path optimization. Again, we have run simulations in this big infrastructure that I've shown in the slide. These are two, let's say, different supercomputing clusters in Sweden. I mean, Gerardo is here. Probably you can jump in.
Maybe we can discuss this later because we still have like a lot of panelists and time is running, and you have 5 minutes left for everything else.
Okay, there are two
so
tools.
Just to let you know, but there is a big lunch break, so all the questions that are not answered during this session can also be answered in
Yes.
private
We'll
during
have
the
to-
lunch break. Yeah.
So I can go to the
Yes,
next one,
please.
right? So Yorgos, we should go to the air quality, so the atmospheric pollution.
Okay. Here, unfortunately, this is an embedded website from our partner SMT. Give me a second.
It's okay. We can go to the next one.
Yeah, I can look into it. I can sort this. That it will take a bit.
But maybe since there is a gap, I can
Yeah,
answer
please.
the second question. So,
of
who will benefit from this? This is for drone operators because the drone operators are affected by the wind. You know, like they cannot, like now, the state of the art, you know, it's like if certain conditions are there, you cannot fly. But this can allow you to still fly, taking another path and not take like the whole city is like one wind direction and that's it. It's not everywhere the same. So what it makes, it enables more traffic to happen.
Just for drones, no aircraft animals at this point.
It is on a city level, so it's 7 meters height from the ground. No airplane is flying inside the city so low. So in general, these simulations are provided by an architecture department who first started working on energy efficient buildings, and they were measuring it like for the buildings, but then they also reuse it for how comfortable it is to live in a city where there are a lot of winds for the citizens, but there is also an application for drones. So we are using these simulations, you know, we're just finding niches in other sciences to take advantage of in order to enable more capacity in the city for flights. So, yeah.
Thank you so much.
Also for the vertical location, so you can identify the safe spot.
Yeah, and the vertical location, of course. Yeah.
Thank you.
Where is
So,
like the safest?
this is an embedded platform from SMT. We are currently gathering the data so we can have this in the RefMap platform as its own thing. And here we can see we have, in a similar way, different filters on top where we can select the different airports, right? And the different emission types that we want. Let's select the ozone. And here we have different types of analysis, right? Here we can see in a specific day regarding, with respect to time, how the ozone levels vary. We can select also the date that is available in the dataset, right? And here we can see in the map with notes how good or bad the ozone levels are in a specific spot. Basically, the tool is informing the user of the different types of emissions that exist near airports.
It has also some other capabilities. You can select areas of interest, but
Yeah.
okay, I mean, yeah, the main.
I'm cutting down the time.
Proceed or question? Okay.
Okay.
So let's go to the next tool on number 3, which is the climate impact tool.
Great. This
Also
tool,
FATMA is here.
yeah, this tool was in collaboration with UC3M. Here we have many filters because it's kind of a large analysis, right? And here we want to see how climate is impacted by selecting different trajectory types of planes. We can select the date, okay, it's self-explanatory, and here we have 3 different types of data types: the complexity, the contrails, and the net ATR. We will go with the contrails. Then here we can select the 3 scales: the BAO, which is the business as usual, so we can see how it's normally; the micro and macro scale, which micro is the analysis done in individual trajectories, individual routes, and the macro is considering different types of routes altogether, right? We can go with the micro one. Here, when we select the scale, we can see how the micro is compared to the business as usual in the different types of emissions as well here. And we can see in the different types of costs. Cost is basically an increase in the expenses, if I'm not wrong. And we can see here how different emissions are affected with respect to different cost levels. So, yeah. This should be scrollable. Here, but we have the map, right? Because we want to give the user a bit more informative about how it's on the Europe area. Here we can select the cost, the flight level, which is in thousands of feet. Let's say we go to 7,000, and we can select the time. Then you can see that the map has a visualization on top where we can see how the contrails are based on the selected type of features. If we increase the cost, for example, right, we can see that we have an increase in contrails in the Netherlands region. I can select also again the filter so it can get more feeling. And using the color bar on the side, we can see how much is the contrails level. This is basically the climate impact tool. If there are any questions. Yeah.
I don't really understand where the term of cost refers to. Basically, for after treatment, in order to reduce the NOx, for example. So it has to do with the integration of after treatment technologies in order to reduce these emissions.
Yeah, the idea.
I believe
Probably
yes.
yes.
For Fatem is the right person.
Well, I'll be presenting that like in my presentation, but basically it's a comparison between the operating cost, which is a weighting sum of the fuel consumption and flight time. Like we consider just simple operating cost. And we compare the cost of these optimized trajectory with respect to business as usual trajectories. That's the increasing cost.
Can you change the business as usual scenario as well to play around with different simulations?
Actually, we can consider business as usual trajectories as cost optimal, but still business as usual are considered to be flying at shortest path, so they should be more or less similar. Shouldn't be changing that much.
Sure, just a clarification from your question. When you say the cost for contrails, are you talking about the cost for diverting the flight to go to an area with no contrails?
Exactly.
So it's a diversion cost?
Exactly. No, not the total cost that you have to deviate flight from some areas, or you want to intentionally cross some areas.
Okay.
You will have, I mean, you have to deviate from shortest path to avoid some areas.
Okay.
Okay? And that deviating may result in increase in the fuel consumption, for example, or maybe flight time, because you may have to change the flight level or the speed of the aircraft, or fly longer, so you may increase the cost.
So it's based on the assumption that contrails are bad, so we're trying to avoid them?
It could also be good. For example, here you can see that the blue areas show the kind of cooling contrail impact, meaning that if we cross this area, then we will reduce the climate impact. But the red areas are basically those areas which have warming impact. So we consider two different impacts.
Well, I have some suggestion regarding the naming here, because I don't know what other things, but I think climate impact 2, basically this is flight planning. This is the results of flight, because they have half optimization at drones level, but I think here maybe we can call it aircraft trajectory optimization or flight planning with respect to climate or climate optimal flight planning. So maybe in terms of naming, and also here, the data type, we have complexity, then we have contrail. So maybe one of them is the operational performance indicator, and the other one are climate indicator. So maybe differentiating between them. And also I think here net ATR is a bit vague, because maybe net climate impact, then the metric is ATR, average temperature response. So maybe we can discuss this.
We'll discuss the afterwards.
Good. Maybe we can conclude here with the demo.
Yeah. There is
one more?
Another one for the survey.
Like
it's a very quick one. I will do it
Okay.
in a class.
Okay.
It's the noise one, right?
The noise, yes.
Great. Last we have the noise. Here it's much simpler. We have the drone type.
So for drones again now, we're back to drones.
Yeah, we have the drone type. Let's pick the cargo, the altitude that we will fly, what if it's daytime or nighttime, and the route that it will take. Again, the color bar is shown. Yeah. Okay, I got it. And we can. Yeah. And we can see here on the map, on the route, how the noise is perceived, right? Or above we have the color bar to see how the different, how much decibels does the drone emit. And by changing, let's say, to a passenger drone, which is much larger and can produce much more noise, and select the filters, we can see that it's much more, that it produces much more noise. Here there are many things that will be added, like the ambient noise of the city, so we can see how it affects the overall noise, of the area. And this way we can see if we can avoid some different routes in order to avoid the densely packed areas, in order to not stress the